Hello, geometry students, and welcome to Chapter 2.2, Conditional Statements. We're going to learn about what this is, so let's go ahead and get started. Now, this first table is going to seem very confusing at first, but once we get into some examples and see how the mathematics and logic and reasoning blends with the human language, it's going to make a lot more sense. So the first term we need to understand here is conditional. When we're talking about conditional, we're talking about conditional statements. So a conditional statement is an if-then statement. Now, we're going to use, for the symbols, we're going to use specific colors. So it's kind of actually important that you use the same colors in your notes for this. So this is what the symbols are going to be. And at first, it's not going to make any sense. It's going to be very odd, but eventually this will make sense. But I wanted to give this up front. So this is an if-then statement, and this is the symbol P arrow Q. And we're going to find out what that means in just a moment. So I hope I caught your attention. Now, the next thing, hypothesis. You've heard this before. You've heard of this in science class when you make a prediction. It's a little bit different in this context. So this is the part following if. And this kind of makes sense. If you are trying to make a prediction about the orbit of a particular asteroid, you could say something like, if it moves at a certain velocity, then... Okay, and the then part, symbol first. The symbol is P, not H. So I would think, let's make the hypothesis H, but it was chosen as P, and that's just the way it is, sorry. Conclusion, now if the asteroid moves at a certain velocity, so the conclusion is the part following then. Okay, and I hope you can guess, based on the conditional symbol, that the conclusion is labeled as Q. Okay. Now we're ready to kind of put it into a diagram. So what do we do with this diagram? Well, we're going to use P and Q, and we need to kind of give a demonstration of which one belongs to which. So here I'm going to, we're going to put P here. Okay, and I'm going to color this red as a highlighter. Okay, so this is my P. So P is a circle inside a bigger circle, okay? So P is a part of something bigger. Okay, what is that bigger thing it's a part of? It's part of Q. It's part of the conclusion. This is gonna be a rough. You can do it a little bit nicer on yours. Take your time. Okay, I'm just gonna make mine quickly, okay? So P is a part of a bigger Q, okay? And we're going to give this some context. I'm just going to erase that. That's fine. That's close enough. Okay, so examples. This is probably what's going to really solidify what that's all about, and I'll go ahead and reference that in a little bit too. What are the hypothesis and the conclusion of the conditional? Now, we already learned that conditional is an if-then statement, so it has to have both those components. It has to have an if and a then. So we see if and we see then. So we know it's a conditional, okay? Now, the second thing is, let me go ahead and read it. I should probably read it first. If an animal is a robin, then the animal is a bird. Okay? If an animal is a robin, then the animal is a bird. Okay, the hypothesis. We need to identify the hypothesis. It's the part following if. The part following if is an animal is a robin. That is the hypothesis. Okay, it's the part following if. The animal is a bird. That is the part following then. Then is there. I highlighted it with 2 purple lines. So the animal is a bird is the conclusion. So P is an animal is a bird. Or excuse me, animal is a robin. That's the hypothesis. And then the conclusion is animal is the animal is a bird. Okay, I'm going to move this over and write the. Okay, the. Now, let's put it into context. Let's go back to our diagram. Or actually, let's go ahead and move this back up to our diagram. So let's look here. We wrote that this was a robin. That was our hypothesis, and then that was going to be a bird. Okay, that makes sense. A robin is a type of bird. So if this is like and it is a Venn diagram, we see that the robin belongs to the bigger group of the bird, okay? Now, this also means, though, that there's other things that are not robins that are also birds. So, for example, we could have a point over here, and this could be an eagle. We could have a point over here, this could be a hawk. We could have a point over here, this could be a goose. Is a robin a goose? No, it is not. Is a robin an eagle? No, it's not. But they are all birds, so they're different points within the bigger umbrella of the bird family, okay? So that's kind of like an example of how to interpret if P, then Q. So if it is a robin, then it is a bird. That is a true statement, okay? Moving on to more mathematical terms. How can you write the following statement as a conditional? Vertical angles share a vertex. First, we should probably understand what vertical angles are. Vertical angles are when you have a line like this, a line like that, and then the vertical angles would be these ones, okay? Vertical angles have the same measure, so if this is 40 degrees, that is 40 degrees, and those are vertical, okay? Just to give you some reference if you didn't know what that meant. Now, vertical angles share a vertex. How do we write that as a conditional? Well, we know we need an if, and we know we need a then. Okay, so how do we do that? Well, if an angle is vertical, okay, so there's our hypothesis. Vertical angles. If an angle is vertical, okay, an angle is vertical, right there, boom. Then they share a vertex. Okay, so if an angle is vertical, then they share, oops, that's right, they share a vertex. Okay, that's our conclusion. Now, is that true? Yes. If it is a vertical angle, then it needs to share a vertex here. That's a shared vertex. Okay, so that's a true statement. If an angle is vertical, then they share a vertex. Okay, now in a little bit, we're going to show how the opposite is not necessarily true. Okay, but I wanted to establish that the conditionals require a hypothesis and a conclusion. Now, sometimes hypotheses are not true. For example, if I am in Alaska, then I am in Russia. That is not a true statement, and I can talk about that in just a second. But the truth value of that statement is false. So a truth value is either true or false. Okay? If a conditional is true or false, if it's true, it needs a true hypothesis. It needs a true P leading to a true Q, okay? It's got to be both true. Now, negation, this is another concept we need to learn. This is a building block. Negation is this symbol, and that just means not. Oops, symbol goes down here. So that means not. So if it is not a robin, or if it is not 90 degrees, or if it's not, we're going to use this symbol in front of it, okay? Now, we're going to pick up with this table in the next episode, so make sure you stay tuned. See you next time.